Alright, Solar Coffee Maker Project by Colin Marr. Yes, it's pronounced Marr. So, price demand equation, you have your 2 points, and then you use y minus y2 over x1 minus x2 to get your slope. That's what I did right there. And then this would be my slope. And then you must find the y-intercept, so you plug in the slope and one of your points, and that is how you get the price demand equation. Revenue function and cost function. To get the revenue function, you must multiply the price and demand equation by x, and then that's how I got the revenue. Cost function, it's 5,000 plus 5x, and I got the 5,000 because it's the weekly fixed cost, and the 5 is cost per unit. Profit function, subtract the revenue function by the cost function, by the cost function. So as you can see, I did it right here, and since 22.9 or 95x and negative 5x are like terms, I subtract them and I get my profit function. And the break even is 304, because when you look at the graph of the cost and the revenue functions, they intersect right at 304. Well, when x equals 304 and when y equals 6,519. Define marginal profit at 2,000 coffee makers. The marginal profit is the derivative of the profit function. So I found the derivative basically from my profit function, multiplied the 2 by the coefficient, and became x, and then I left my other derivative. To find 2,000, I plug it in to the new equation, the marginal profit equation, and I end up getting negative 1.65. So this means at 2,000 coffee makers, the company loses money because the marginal profit is negative. So how do we solve this? Find the maximum of the profit function, because it's a quadratic equation. The maximum was at x equals 1,831.6633. So we round that up to 832, and this means the company must produce 1,832 coffee makers per week in order to make the most money.